All right, this is 6.1, slope of a line. We're going to learn how to calculate slope, how to determine slope, the different kinds of slope, and how to create lines with it. So to calculate slope, we worry about rise over run. That is very simply just the amount that you go up with the rise, and the run is the horizontal distance. This is very similar to the rate of change. So the other way that we look at this for slope is if we're looking at slope is equal to y minus y over x minus x. So if we want to determine the slope of a line segment here, there's two different ways that we could do it. We can identify clear points and count over to them. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over, and 1, 2, 3, 4, 5, 6 up, which reduces to 3/5. The other way that we could do it is we could do it using our slope formula, so the change in y. So it doesn't matter which point you use, as long as it's the same consistency. So for instance, -3 comma -6 is A point, and then we subtract because the difference, and then B point is 4 and 3. Yeah. So then -3 minus 3 gives us -6 over -10, which gives us 3/5. So that kind of confirms that we did it correctly. For this one, let's just count it out and reduce it. So we can use C, D, or we can use this one right here because it looks like it crosses perfectly. So then you go down 1, 2, 3, 4, 5, 6. So down 6 and over 1, 2, 3. So that leaves us with -2 over 1. And I leave it like this because we're not dealing with an equation right now. But when we deal with an equation, we just leave it like this. We have 4 types of slope here. We have our positive slope, so we can see that it increases. We have our negative slope. We have when our slope is 0, so it's when it's a y constant. And then if our undefined slope is here, that means it's our x constant. So this would be x is equal to -1.5. This would be y is equal to -1. So there's no change, but it's constant. This one creates undefined slope. This one creates slope is equal to 0. So when we draw a line segment with each given slope, it doesn't matter where we start this. So we're just going to start it right here. So if we go up 7, 1, 2, 3, 4, 5, 6, 7, and then over 5, 1, 2, 3, 4, 5, we'll have a second point here. And that's enough to draw a line. So get your ruler out, draw a nice straight line. And we're just drawing a line segment, so we're just connecting the dots there. Okay, same thing with this one. The only thing that's different is that we need to realize that this negative out front can be with the 3, or it can be with the 8. Oh, geez. Typically, I like to keep it like this and keep my x positive. So let's start this one here, because it doesn't really matter. So then we have to go, no, that's a bad place. Let's start it here, because why not? So I need to go down 3, and we need to go down because of the negative. So then 1, 2, 3, and then over 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we draw our point, and then because this is a line segment, we just need to draw a nice line connecting the 2 points. We don't need to extend it at all. That's the point of the line segment, is that we know that it stops. Okay, next part. Determining slope given 2 points on a line. It doesn't matter what points you use, and I think I already kind of iterated that a few times. You can use any point on here because they all create right-angled triangles. So it's like using that polygon property that similar polygons will create the same angles. It's kind of the same idea with slope. So let's determine the slope of a line that passes through C, -30, -5, comma -3. So 1, 2, 3, 4, 5, and -3, 1, 2, 3. Don't mind me, that's how I usually do my graphing. And then D is 2 over up 1. And it is a line, not a line segment. So this guy is going to extend beyond the graph here. It's going to extend to, what's my word here? Well, it's going to go here, but then it's going to keep going. We don't know if that's entirely accurate, but if we're using a ruler and not a wonky straight line tool, I don't like it. That's better. You would just extend it to the farthest points on the graph, or you would draw your little arrows here because it's a line, not a line segment. So if we count this out, this should be 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. So we know the slope should be 4 over 7, but let's confirm that using algebra. So our slope is equal to -3, -5, minus 1 over 2, -4 over -7 is equal to 4 over 7. So even if you have these in the way that C is first, which it was in this case, this was C and this was D, the negative here will make it positive. And we know because of the slope, or sorry, because of the graph, slope should be positive. Okay, and then we're going to do one more here. Interpreting the slope of a line. Yvonne recorded the distances she had traveled at certain times since she began her cycling trip. She plotted this data on a grid. What is the slope of the line through these points? So if we count it out here, we have 0.24 and 1 and 0.48 and 2. So then that would be -24 over -1, which gives us +24. What does the slope represent? The slope represents 24 kilometers per hour. How can the answer in part B used to determine how far Yvonne traveled in 1 3/4 hours? Well, this we can use our proportional rates. So this is 24 kilometers, this is 1 hour. This is equal to unknown kilometers in 1.75 hours. That was weird. Hours. We cross multiply and we get 24 multiplied by 1.75 is equal to x, which gives us 42 for x. And then we can kind of check that if we're looking at 1.75. Yeah, it's about 42, because like if we drew a line right here and connected these dots, yeah, it's about 42. Not bad. Okay, next one. The time it took Yvonne to travel 55 kilometers, same deal, 24 kilometers. 1 hour is equal to 55 kilometers over x. So then these guys just multiply and trade places. X is equal to 55 divided by 24, which gives us 2.29 hours. And you can use the graph again to confirm that. That's it though. Head off onto the assignment. Let me know if you have any questions.